Hey everybody, it's Dr. J, and today we're talking about kinetic molecular theory or KMT. Let's talk chemistry. So KMT is basically the simplest model for the behavior of your gases, okay? And we're going to relate this KMT theory to a couple of simple gas laws we talked about earlier, right? If you forgot about those simple gas laws, I highly recommend checking the previous videos. Now, there's three basic assumptions that we must consider for KMT, right? The first one, the size of gas molecules are very small. That's the first thing we need to consider, right? These are very small molecules. Second thing, the average kinetic energy of your particle will be proportional to the temperature in kelvins, okay? So depending on how quickly your gas particles are moving, that's going to impact your temperature. And a third thing, the collision of one particle with another, or if it hits a wall, is completely elastic. So essentially, if we look down here, what we mean by elastic is that it's going to be able to bounce off. So if these molecules, these particles are hitting each other, they're not hitting each other and colliding like a regular car, right? To where, okay, we're going to hit each other, bam, that's it. They're hitting each other, then bouncing off with each other, right? So if a molecule hits right here, it's going to bounce off and go this way, and then it's going to go the other way. Or if it hits a wall, right, it's not going to hit the wall and just fall down. It's going to hit the wall and bounce right back off, right? So these are the three assumptions we must consider with KMT. We got small molecules, um, the energy of your molecule will impact your temperature, and then everything is elastic. So everything is bouncing off each other. So let's talk about Boyle's law, right? We're going to talk about Boyle's law and we're going to relate it to KMT. So if we remember, Boyle's law is telling me that the pressure is inversely proportional to the volume, right? So if we increase our pressure, our volume is decreasing. If we increase our volume, our pressure is decreasing, right? They're inversely related. Now, let's talk about the why. KMT gives me the why behind this, okay? So KMT is basically telling me that the decrease in volume means that particles hit the wall more often. More molecules will collide with the container at any one instant, increasing the pressure. So essentially, right, as we decrease our volume, right, we can see this here. When we decrease our volume, we don't got a lot of room, right? Those gas molecules do not have a lot of room to work with. And because temperature and the amount of moles are staying constant, right? We didn't change the amount of gas in here, we decrease our volume, right? So because everything's staying constant, that means that I got less room to move with, right? That means that we're going to have a lot of more collisions, right? Because it's less room. And because we're having more collisions with each other, right? Everybody's bouncing off with each other, hitting each other left and right. That's going to impact our pressure. In that case, the more collisions we have, right, the higher our pressure will be. Okay, and this is what we see here. If you decrease the volume, we're going to have more collisions with our gas molecules. Therefore, our pressure will increase. They're inversely related, right, with our volume and pressure. If we go the reverse direction, if we increase our volume, notice what happened. They got room now. Since we got so much room, we could just stroll around. They're just strolling around. There's not a lot of bouncing off with each other. There's not a lot of collisions. Because there's not a lot of collisions, because the volume has increased, our pressure is what? Decreasing, right? It has decreased. So this KMT is telling me why, right? With Boyle's law. Let's talk about Charles' law. Charles' law states that volume is directly proportional to temperature, right? So if we increase our temp, our volume will increase. Now, KMT states the reason why is because the increase in the temperature of the gas, the average speed, and thus the average kinetic energy of the particles will increase. So if we look here, understand that volume and temperature is changing, so our pressure and the amount of moles are going to stay the same. So that's constant. So if I increase my temperature, right, remember that if you increase your temperature, you're giving it more energy, right? And if you're giving it more energy, right, that means that it's going to have more collisions, right? More impacts. So because of these more collisions, because of the average speed has increased because of that more energy from the temperature, our volume is going to increase as well to accommodate the increase in energy, right? So this is what we see here, right? Temperature increase. So our volume had to adjust to that temperature increase, right? As we looked at the example with the balloons in our previous videos, right? That balloon had an increase in energy, therefore the volume expanded because of that. But if you decrease your temperature, right, the volume will decrease as well. If we go the reverse direction. And that's because we understand, right, is that temperature is impacting the gas. And we understand that that temperature is going to slow down the kinetic energy. They're going to be moving slow. And if y'all moving slow, it's not going to be as many collisions. Therefore, our volume does not have to be that high. It can actually decrease and adjust to that temperature. Okay. KMT, they telling me the reason why. They telling me the reason why. Avogadro's law, right? Avogadro's law, we remember the volume is directly proportional to the number of moles. So as we increase the number of moles, our volume increase. When we think about KMT, KMT states that increasing the number of gas molecules causes more of them to hit the wall at the same time. Shout out to Future, man. To keep the pressure constant, the volume must then increase. One more time. Increasing the number of gas molecules causes more of them to hit the wall at the same time. To keep the pressure constant, the volume must then increase. Let's look at this one. All right. So we got two things we want to understand. Volume and our N, the number of moles, are going to be the things changing here. Our pressure and temperature are staying constant. So those are not changing at all. So if we got our moles here, we can see that our current volume is here. But if we increase the amount of moles, what's going to happen with our volume? Well, the volume must increase as well, right, to get to that original pressure, right? Because pressure is going to stay constant. It must stay constant with Avogadro's law. So this is what we see here, right? The more gas you add, the more the increase in volume you're going to see. Okay, that's essentially it, right? Let's talk about these last two over here. So these are related to some other laws mentioned with gas, Dalton's law. So Dalton's law, you remember, is the total pressure of gas mixture is the sum of the partial pressures of its components. KMT, right? The particles are very small, as we mentioned, and they are not going to interact. And because of this, the average kinetic energy will be the same. So the total pressure of your collisions will be the same. So the key thing with this one is that since we have these small particles, there's not that much interaction. Okay. So the kinetic energy is going to be the same throughout everything. Okay. So even without the collisions taking place, the total pressure will be the same. And then I'm just going to mention this one here. Pressure is actually going to be proportional to temperature, okay, as well. So KMT has a reason behind this. As temperature increases, gas speed will increase, right? So we understand, right, what we mentioned before with the temperature increasing, impacting your gas molecules. So because temperature is increasing and gas speed is increasing, that also is going to impact your pressure as well. So pressure will increase because the collisions that we see with those gas molecules. Okay. So everybody, this is KMT relating it to gas laws, right? And other different gas principles. Okay. KMT, kinetic molecular theory, is basically just telling me the why behind these laws.